Suppose you were asked to calculate -2 multiplied by -3. You might remember that a negative number multiplied by another negative number gives you a positive answer. Therefore, the answer would be +6. But do you know why? This is Mr. Butler Maths, and in this video, we are providing an explanation of the rules behind multiplying positive and negative numbers. I think it's a shame that often students are just told to memorize these rules, because I think there's a real opportunity here to delve deeper into the logical nature of mathematics. In providing this explanation for the rules behind multiplying positive and negative numbers, let's start with times tables. This is something very basic, but also very helpful in establishing the patterns that will allow us to see the reasons behind the rules. To keep things simple for ourselves, let's just look at the times tables for the numbers 1 to 4. 1 times 1 is 1, 2 times 1 is 2, and so on, all the way up to 4 times 4 is 60. We've only looked at positive numbers so far, but to give me some more space to look at what happens when our multiplications involve negative numbers, let's shift our work so far to the top right corner. And I'm also going to extend my grid to include 0 and -1, -2, -3, and -4. At the minute, my grid is looking quite empty. I only have the top right section filled in. And what I'd like to do is fill in the rest of the grid. Instead of relying on some rules that I vaguely remember from school, I'm just going to follow some patterns. Let's start by seeing if we can extend the 1 times table. 4 times 1 is 4, 3 times 1 is 3, 2 times 1 is 2, 1 times 1 is 1. So I'm going down by 1 each time. Therefore, the next number, 0 times 1, must be 0. I'm just following that pattern. The same thing applies for the 2 times table. I have 8, then 6, then 4, then 2, and then the next number must be 0. And this also applies for the 3 times table, the 4 times table, and in fact, any number multiplied by 0 must be 0. And for exactly the same reason, the numbers in the 0 row below must also all be 0. Just as 0 times 1 is 0, 1 times 0 must also be 0. And it follows from this that 0 times 0 in the bottom left corner must also be 0. To help me keep track that all the numbers in the top right are positive, I'm going to shade this in red. These numbers are the product of multiplying two positive numbers together. Now let's start to venture into the negative part of my grid. Again, I'm just going to extend my patterns. The most straightforward pattern might be the zeros. I'm going to do that one first. As we already identified, any number, either positive or negative, multiplied by 0 must also be 0. To help us have some structure to our grid, I'm going to shade all of those zeros in dark blue. Let's now try and make some inroads into the top left. I'm just going to follow the patterns that we see with our positive times tables into the realm of the negative numbers. So let's just follow the 1 times table. 4 times 1 is 4. 3 times 1 is 3, 2 times 1 is 2, 1 times 1 is 1, 0 times 1 is 0, so we're going down by 1 each time, so -1 times 1 is -1, -2 times 1 must be -2, and so on, giving us -3 and -4. And we can fill in this whole grid by just continuing the times tables down through the negative numbers. And as we can see, all of the numbers produced by multiplying one positive and one negative number together are negative. To help me keep track of this, I'm going to shade all of those numbers in blue. Now let's try the bottom right section of our grid. And this is going to work in exactly the same way as the top left. I'm just going to follow my 1 times table, this time going down rather than to the left. 1 times 4 is 4, 1 times 3 is 3, 1 times 2 is 2, 1 times 1 is 1, 1 times 0 is 0, we're going down by 1 each time, therefore 1 times -1, the next number, must be -1, and the number after that must be -2, and then -3, and -4, and so on. And you'll notice that, just as with the top left corner, all of these numbers are also negative, because again, it's multiplying one positive number by one negative number. To help me keep track of this, I'm going to shade all of these numbers in blue as well. Before we venture into the bottom left section of our grid, I just want to point out one thing that you've probably noticed. The numbers themselves in each section of our grid are the same, except for whether they're positive or negative. If the only thing we're changing is whether a number is positive or negative, the magnitude, the size of the number, isn't going to change. Let's now go back to our bottom left section. Because this isn't next to our top right section, I'm going to follow the pattern from the bottom right. So if we look at our -1 times table, Negative 1 times 4 is negative 4. The next number is negative 3, then negative 2, then negative 1, and we're going up by 1 each time. Therefore, we know the next number is 0, and the next number after that must be 1, then 2, then 3, then 4, and so on. And we can fill out this whole section using that. Now, at first, it might seem a little counterintuitive that multiplying a negative by a negative gives you a positive answer. But actually, for maths to be a logical and consistent subject, following the patterns shows this must be the case. A negative number multiplied by a negative number must give you a positive number. And again, just as we've coloured in the rest of the grid, let's shade all of these positive numbers in red to help us visualise which combinations of positive and negative numbers give us positive and negative answers. Now we have our final table. We have more of an understanding of the reasons behind our rules for multiplying positive and negative numbers. And along the way, we've had a chance to talk a bit more about the importance of logic and consistency in mathematics. I hope this video has been useful, and as always, it really helps me out if you could leave a like on this video, and don't forget to subscribe if you want to find your way back for more maths videos. Thanks, guys.